Hey guys, it's from QC with GameDev, and this time I wanted to talk about how I keep track of which state the application is currently in. So this is really still in the planning phase. It's really like, okay, how do I know what's going on right now? So this was a topic I really had to get familiar with as I was thinking about how we want to transition from one UI to the other given the flow of the game, right? So basically, the way I know what's happening at any given moment is by using a scene level state machine to represent where we are in the application, or rather in the flow of the application, right? So the idea is pretty simple. In our case with this game, I associate a state to like a given UI panel, so that was like a good way for me. And from there, you define what the transitions are that lead out of or into that state. So for instance, right, say I define a state for some panel. Okay, it could be as simple as like the quit panel from my main menu. So that'll be my quit state, right? So given my quit state, right, I can define transitions okay and cancel, right? And that's it, right? So in that scenario, given that I have my quit state and I have like transition cancel, it would be like, okay, so go back to whatever state was before the quit state, right? And if I hit okay, then actually in that scenario, I probably wouldn't even have another state after okay, because if you're quitting the game, you're quitting the game, right? But that's basically the way I would do it. And using this level of simplicity, it made it really clear for me with respect to like my view layer being able to tell my state machine what's going on. And it makes debugging really clear too, because if your state transitions align with your UI, it allows you to know what's going on much easier and what the user's doing. So speaking of my view layer, I mentioned that quickly earlier, right? So something I really wanted to do was make it so my game was using the MVVM model. So it's like not a super big deal, I guess, to have like a specific design pattern in mind when you're starting a project, as long as you understand yourself. That's really what matters. But I've been in projects before where we didn't really have a specific design pattern and it was just kind of sort of free form, and there's nothing wrong with that, but in that context for me, I just found it wound up making the code really easy to get lost in. So you just find yourself using these sort of generic terms like managers or handlers, and in the end what winds up happening is you're not really sure who's responsible for what. For instance, if I say something is like a handler, right? It could mean this guy is like responsible for some visual aspect of something. He could be responsible for the state of whatever's going on there. So it works both ways. Using this word like something like handler or manager or whatever, it's really easy to get lost in the details of like which component is responsible for what. So in particular for this project, I want it to be really clear. Who's responsible for data, who's responsible for actually showing things to the user, who receives input, that sort of thing. So that's why I chose the MVVM design pattern. MVVM stands for Model-View-ViewModel, right? Where the model, that's the layer the data lives on. The view is the layer that the user sees and interacts with. And the view model is between the model and the view model. So it's basically allowing the view to access pertinent data. And so in particular, what's important here is that the model shouldn't know about the view model or the view. He knows about nothing except the data that's inside of himself, right? The view model only knows about whatever model he's consuming, and it could be more than one, and the view. So in particular, the view model, he does not know about the view, right? That's what's important there. And the view, he only knows about the view model. There's nothing wrong with him like accessing, I don't know, like maybe some static constant from the model, but he's not directly interacting with the model. He has no direct reference to the model. It might sound a little confusing at first to have all this information just like that, but really this sort of design pattern allows for really clean separation of concerns, right? So basically, once I defined my flow diagram, right, I had an idea of what I wanted my state machine to be like. And using the concepts of MVVM, what it means is that I have to first make a brain for my UI. That's going to be sort of my model. And then I put my brain into a view model layer so that my view can then listen to the brain for changes. And I say my view, what I mean is my view layer. Whoever's on my view, he's listening to whoever's responsible for making those state changes to the state machine, right? So something I also wanted to try doing in this project was making each individual sort of panel or main view responsible for how it would show and hide itself. Something I'd done in the past was I'd use patterns where I had a kind of parent view that would then delegate to its view subcomponents how they should show or hide themselves. So basically you had this one guy that would listen to the state machine, and he would listen for state changes. And then given that state change, he would get the respective child who was associated to the state, and then he would say, okay, guy who needs to show himself, you show himself, and then the last guy who is showing himself, hide yourself, right? So I wanted to not do that anymore. I don't want to have that central manager. I think every child should just be able to listen to the state machine and make their own changes, right? So if I say each UI panel corresponds to its own view element, and each panel with a view is responsible for specifying how it should show and hide itself, it means every panel now has much more autonomy with respect to how they animate or how they perform certain visuals, right? So like every panel, because in my earlier strategy of when I had this sort of parent view, there was like one show and hide, or otherwise maybe I could have said, okay, I have a global show and hide function, or a function that parent defines. And then on a child basis in that function, I would say, okay, if you're that child, you hide this way, or you show this way. So this way, putting all that stuff in the child, I can just say, okay, child, define a show function, define a hide function. And in your implementation of that show function, you define for yourself how you're going to show yourself. And that could be whatever you want, as long as at the end you say, okay, now I finished my function, I'm shown, right? So that was something I wanted to try doing. So basically in my state machine, I defined basically the whole flow of states as a dictionary of state to a dictionary of transition to state. So basically that tells me, given the current state, that would be my key in my flow dictionary, and given the transition, so that would be like the key in my second dictionary there, I would know what the final state is. That would be the value in my second dictionary there. So basically I would say, given some current state S1, if I receive transition T, then this leads to state S2, right? So working like this, I basically worked my way through the main menu and settings panel, just really warming up, making views, then models, then view models, and I basically made my way to the game scene from there. So to make diagrams, class diagrams, I used draw.io, and I dropped the draw.io file directly into my Unity project just to keep visibility on the definitions of different components. One small drawback to this, you wind up having these meta files for these draw.io files, but whatever, it's not a big deal. Personally, I would rather have the clarity of knowing, okay, this feature is associated to this draw.io file, so it's totally worth having the meta file in my opinion. It was really easy to just go panel by panel, define views for each of them, right? So if I take as example my main menu quit panel again, right? So the view there is literally just made up of that custom show and hide function, a continue button, and a back button. And that's almost everything I have in there, right? So that the only other code is specifically how he's showing and hiding himself, right? But it's a very short class. It gives you everything you need, right? All this panel is responsible for is like showing itself, hiding itself, and listening to those button presses in order to tell the state machine this is the transition that's taking place. And he also obviously needs to listen to the state machine to know which state is currently active, to know when to show or hide himself, right? So sometimes as I was making these views, right, I would notice that some elements were shared between panels, right? So for instance, a view to show an enemy's image and properties, or a view to show a treasure or an item, these were all elements that appeared multiple times on different panels. So I consolidated those into a single component. So for instance, enemy display view, right? So I show an enemy on like several different panels. It could be when I'm about to roll for damage, it could be when I have rolled for damage, because that was two different panels, right? So I would always have this component of the enemy display view in there. So this was like a really good Unity dev evolution moment, like recycle, as soon as it's possible to share things, just share them, because this guy, all he really needs to do is sort of listen to the enemy that's currently activated for that sort of flow, and boom, he has everything he needs, right? So, and obviously, so the same was true of the view models, right? So I was sort of noticing patterns, right? So there's data that's shared, so as soon as I was seeing that some data was shared, I was becoming aware, okay, so this view model, he's going to get accessed by this view, this view, this view, right? So he has to have this data. So already by seeing the sort of data that would be shared, it started giving me some insight into which view models need to exist, right? So examples of some shared data could be game state, like who the currently playing player is. So for this, I defined a round view model. So that guy was responsible about like data about the current round being played. So that could be like current action count, current player, whatever it is, right? Or even something like access to scriptable objects related to a specific thing. So for instance, I defined all my character visuals in a scriptable object called character SO. So stuff like character name, character description, character sprites for thumbnail, for the full character visual, that all lived in the character SO, right? And I had several of them, and often I had to make reference to that SO, and I had to find the scriptable object for that specific character. So for that, I made a character SO view model. And the reason it's a view model is because the place where I would be accessing it would be from the view, right? And often I would be reusing this functionality of like, okay, find my given character scriptable object by the character name, right? So yeah, another little Unity dev evolution moment I had here was in using these view models to centralize scriptable object functionality. So in the context of containing lists of scriptable objects, I was finding myself centralizing commonly used functions on the view layer. So for instance, suppose I have several different views responsible for showing some character visuals, and every time I'm needing to access to that specific character SO, when my view was telling me which character I needed the data for, it was usually in the form of like a string, character name, and then my character SO view model just gets that character SO from the name, right? So keeping things as simple as possible in this way allowed me to make things in a much less coupled way. So for instance, if I was throwing around the character SO, it's like, yeah, that's one way to do it, but ultimately it's much easier if I'm just like throwing the character name around and everybody just knows which scriptable object that name is in reference to, and they can just go and they can just get that scriptable object for themselves. I found it was a much cleaner way to do things. So diving a little deeper into how I would actually manage interaction between the layers, especially with respect to data changes and like subscriptions, it's possible to implement this using pure C#, using just data and actions. And so the idea is you have your data type and you just fire your own custom action and you say like, oh, okay, that guy changed, right? And you could return the changed value or not, it's whatever you want, right? But I tried that for a bit, and ultimately I found that I was having like a lot of boilerplate code that I was reusing in many places. So I actually opted for the UniRx package. So this is a free package that allows us to basically define reactive data types and collections. And it basically means I don't need all that boilerplate code anymore, right? Because all I can do is define that primitive data type, or even a custom data type, whatever I want, and using UniRx, I can basically just subscribe to that from whoever needs to listen. And it was super easy to use. The only time I found myself still using custom C# was for dictionaries. They don't have a reactive dictionary type, but they do have a reactive collection, which works really well for lists. So that's basically it for this time. So that I really just wanted to talk about planning specific classes and making class diagrams and that sort of thing. So that was something I really tried to do more of this time around. I think it's really great to have those, both for sharing if you're doing the project in a team, but also just for yourself, because it's really easy to get lost when you come back to a project after coming away from some time. And if you just have these diagrams already, it makes things a lot easier. And also, it's great for planning because it allows you to see sometimes ahead of time, okay, here are some issues I might have with a certain pattern that I'm thinking of using. So just getting ahead of problems like that, that was really great. That was another big Unity dev evolution for me. So yeah, next time, next video, I'm going to be talking about services and how I use those in the context of this game. So look forward to that. I'll see you next time. Take it easy, guys.